So let's look at the animation of a cyclone here. Okay, it's a very simple one. So you have the cyclone formation or cyclonic circulation. You have a low pressure system in the middle, which means there is high pressure around it, and the flow is going to go from high pressure to low pressure, which means air is trying to go to the middle. And then you add Coriolis in the northern hemisphere. So in the northern hemisphere you have counterclockwise flow called cyclonic flow around low pressure systems, whereas if you go to the southern hemisphere, the flow is going to be clockwise around the low pressure system because the Coriolis works the other way, right? So you can use your simple idea of going from high pressure to low pressure, add Coriolis, and end up with counterclockwise flow around the cyclone. And as we said, cyclone comes from the Greek word essentially meaning circulation, but it's going in the same direction as Earth's rotation. If you go to the anticyclone, it's now a high pressure system sitting in the middle with low pressure all around. So flow is going to go from the middle to outside everywhere all around. So then you add Coriolis again and you are going to easily end up with a clockwise circulation. So clockwise anticyclonic circulation in the northern hemisphere and a counterclockwise anticlockwise anticyclonic circulation in the southern hemisphere. The atmospheric people, you keep using cyclonic circulation, anticyclonic circulation to very commonly, and you have to be comfortable with it. It's not just cyclones and hurricanes, but every time you have rain and you have low pressure, you're going to have cyclonic circulation. If you have clear weather, high pressure, you're going to have typically counterclockwise or anti-clockwise anticyclonic circulation, and so on. So my voice drops, but hopefully it's still audible. Okay, let's stop that little